Hey, good Tuesday evening, everybody. It is October 8th, 2024, Modified Weather Watch. Meteorologist Will Danby here. We're in that crunch time now for Hurricane Milton. At the time I'm recording this, it's about 6 o'clock this evening. Now, anticipated landfall for Milton is going to be right around Tampa at about 1 a.m. Thursday morning. So this is crunch time. We're getting within about 30 hours of this thing making landfall. And I'm trying to get this out as soon as I can to you guys, as while this will not be a full comprehensive analysis like I did on Hurricane Helene, right now we're just looking at this storm as it's developing, as they churned it out there in the armpit of the Gulf of Mexico just to the west of the Yucatan Peninsula. That's where they created this sustained environment, built this storm. It underwent its rapid intensification, and now it is well on its way, heading right towards Tampa. And I want us to note, guys, this storm underwent pronounced, incredible rapid intensification during the overnight hours on Sunday evening into Monday morning. This is what the satellite loop is looking at, and I want us to note the standard meteorological definition of rapid intensification is 30 knots of winds in 24 hours, or 35 miles per hour daily. Milton exceeded this by over double that, guys. We're talking from midnight, early Monday morning to sunrise. This storm rapidly intensified from a low-end Cat 1 hurricane to now, as we're waking up, this is nearly a Cat 5 hurricane as we come into the late morning hours. I have not seen in my career forecasting such pronounced rapid intensification, and this thing, or this hurricane, is literally thrashing out here in the Gulf. I mean, this is some violent rapid intensification going on that's going around this eye wall. We can see it with the deepest, almost black colors within those rusted colors. That's signification of deep convection around this eye wall. So this is a pronounced and very strong storm when it underwent this intensification early Monday morning. Right now it is north of the Yucatan. This is older satellite data right now. I'm looking at the sandwich imagery. This is helpful to detecting cloud top heights and looking at areas of deep convection where thunderstorms can form and occur. But what you begin to notice as well is we start to see geometry or shapes and patterns here. And seeing geometry in weather, that's a little bit strange. It does make you turn an eye towards this and look at this, but we have triangles of convection here. That just happened, guys. We have pockets of sequestered pizza slices here. I mean, look at this. This is a triangle of convection that's bottled up and held in a certain area here. My goal of this video, guys, I'm going to dissect a loop of this storm developing, and I'm going to show where excitation pulses are, frequencies are being emitted, and how these thunderstorms and areas of convection work in tandem with each other, and they rotate around fixed points. And all you guys realize, or you will begin to realize with this is geometry. These are calculated measures. This is a sequence of geometry, transferring of energy like it's on an electric grid. Water is conductive, water vapor is conductive, or water itself, H2O, the gaseous form here. When water is in its gas form, its vapor, you can still conduct this as a conductor. Water is a very efficient conductor of energy and latent heat release. It's the same thing with electricity, and that's how you have to approach this, guys, is this is transferring through EMF, electromagnetic frequencies, ionization, and microwaving. You're able to manipulate pockets of the atmosphere and water vapor to get this to work, and I'm going to do my best to show this to you. This is the problem right now, is breaking that barrier between meteorological lingo and how meteorologists analyze these upper level maps versus what can be received on the general public side. This is not meant for the public to ingest, guys. That's not your job. This is my job. This is my job to look at the water vapor imagery and dissect this and show you how this is not behaving naturally, okay? And we're going to get into this here. I'm going to show one loop. I broke this down into nearly 200 frames, okay? I have to take this frame by frame and show you this convection, okay? Convection, your thunderstorm development. Anywhere where we see these greens, okay? Green pockets right where I'm pointing to the head of this arrow, that's deeper convection. The richer greens you see, that's more saturation, that's more water vapor. The drier colors you see, the reds and yellows, that's less water vapor. That's dry air or a lack of water vapor. And again, I want us to get the conventions of where we're looking at too. Right now we are in the Gulf of Mexico. Let me get my pen out here real quick. For some reason, I'm having some difficulties with this. Okay, so I'll just end up using this drawing tool here. This is the coast here. Here's Florida. Okay, here's Louisiana right here. This is Texas. I'm outlining all of the Gulf of Mexico so we can visually see this. It may not be obvious for some of you guys what our scaling is right here. So here is the Gulf of Mexico. Here's Cuba right here. So this is all our area of our bathwater that we're going to be working with here. My goal with this, again, I'm not trying to draw a whole lot on this. I've tried to do all the drawing itself. Here's a look at the oceanic temperatures of the Gulf of Mexico taken on October 7th, and we're talking very warm waters, frothy waters. This is the environment that hurricanes can sustain development in, and this is 82 to 86 degrees Fahrenheit. Generally, you need, at minimum, about 78 to 80 degrees that can sustain tropical systems, but once you really get beyond about 81, 82, and those temperatures beyond, that's when you're really in open season for some frothy and warm waters here that's juiced to get these storms to work. So my point being with this, guys, there's certainly plenty of water vapor and energy, warm oceanic temperatures to allow for this to happen. And when I talk about grids here, electric grids, imagine we have an electric grid that's like this. I mean, it's literally just a grid, okay? And along these, there's points here. You can transfer energy from one point of your grid to the other. Let's say we transfer it from this node to this node, okay? And it's going to go from 1, 2, and 3, and it's going to travel in this direction. Let's say as that's going that way, you have another pulse of energy that's traveling from east to west, and it's along these nodes like this, and it goes doot, 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 like that. It's like snapping your fingers instantly. It goes dot, 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 dot across the screen. It's the same way of how electricity behaves. It's like you're transferring energy and electricity. That's what you're going to start to see with some of these here as I continue to roll through with this. And you'll see cases like this. This is a frequency. This is a pulse here where we're lifting energy and guiding the storm from southwest to northeast. Now again, here is in full. This is the loop that we're going to be analyzing. And I'm looking at strictly just the water vapor. There's already very glaringly obvious direct manipulation of water vapor here. Just look at how this is dry air is just moving down south on a linear path. And it's also being forced this way here. And what you get is we have dry air that's bottled up at an intersection here that's forcing this in order for this to operate in its own environment of saturated air. So this is already a case of dry air manipulation, that this is not behaving naturally. This is a fixed high pressure dome here that's helping to generate this. We see this clockwise flow, okay? It's like a slice of pizza, all right? It makes a pizza slice here. This is manipulation going on, guys. This is not normal of what's going on here. Again, there's also a case where this is held this way, it's constrained this way. And when you do that, in doing so, here is your entire environment you have to work with to pump this up and manipulate this. So here's a look again at some of this air. I mean, you can see this is deliberately being directed down here, and then you start to see this working through this area, and we see a conical forcing here. This is again in slices of dry air that's being attached from over here, and it's being infiltrated and directed in this way. Guys, this is manipulation. Can't stress this enough. And again, we can see more of this is being brought down this way, like that. And so you can see what this does is this creates a pocket of pinched off moisture, which allows this hurricane to become so pronounced and rapidly intensify. This is a look again at the I believe this is the mid-level water vapor. Those other ones were upper level. Again, here's the mid-level. We can see this is being pushed down south, and we can see the conical structure of this manipulation at play. Here is this heat dome, this high pressure with the clockwise flow helping to amp this up. It drives everything down to the south, and that's how you can get these things to develop here. All right, guys, let's go ahead and get into how this is finally going to be manipulated. I want to start things off with the first slide. Everything is fixated through this area. We see funneling coming through this red line, these red lines here. This is very early on. What we need to watch for is, where is Milton? This right here is Milton. It's disorganized area of convection here. We can see a lot of thunderstorms going on out here. There's no defined area of center of circulation. That's my point with this right now, is this is the initial stages of this. This is when we're starting to pump this up and get this going. What's going on is, this is going to be our Kickstarter, where we're helping to transfer this moisture, and we're putting it through this way, and we're transferring it into Milton to help this thing get ramped up and excited and pulsed up here. This is how it works frame by frame. Again, anywhere where we see these red solid lines, this is a placeholder that's helping to put a bar or a block on the upper level water vapor pattern here. And you'll see cases of triangles, geometric shapes, geometric patterns that rotate, maintain relative positioning to each other. As you'll see with this, we have triangular convection. There's a larger one that's out here. I haven't drawn it yet, but here's, again, triangular convection. All these points work with each other, and it rotates clockwise, guys. This is one larger picture of more embedded convection. We see the same pattern recognition, the same geometric shape, coincentric to this larger one, okay? This is mathematics. This is how this works, and this is how this is deliberately calculated and timed for this to work in tandem, guys. Otherwise, you can't get this to rotate and form in a set fashion. It has to be done this way. It has to be set up this way so that this can work in tandem and develop, okay? As I continue to work this through frame by frame, you can notice, again, we have a blockade here. Here's another intersection point of just where we're blocking and manipulating some of the water vapor here. I can go back and forth a few times so we can put that into motion and see what's going on. Again, my point of drawing a few of these lines is to accentuate it, to point this out for you guys to see it. There's an infinite amount of more of these that are going on, guys. My point being with this, again, is as these are all working in tandem, I'm only showing a couple of these, but we have honestly hundreds of these going on. I haven't drawn these out, but you can see there's a case of this going on out here, where we see lines of convection that are developing with this. We can see it through here and through here, that there's linear convection that's rotating. This is, again, when you take the idea of these forming on a line, and here's your nodes, it's like you're transferring electricity from here on over, guys, and the convection is just a result of it. You guys see these pulses showing up. Here's another case without me even drawing this, that we can see energies being transferred along this line that's eventually going to froth this up and develop Milton for us. So as I continue to roll through this frame by frame, let's get to the next highlighted point I want to draw out. And again, I can see this, again, a case here where we have something operating like this, and this is all rotating clockwise here. So this is all working together. Here's another case of this in Florida. This is helping to put a cap on some of this dry air that's also being paralleled out here. We can see that this is also being restrained here and manipulated deliberately. This first area we're going to watch for is a pulse. We're going to shoot a pulse, and it's going to excite this, and it's going to go from south to north here. I've drawn this out in this red rectangle, and here is the start of it. It's with this convection, this dot here that pops up. This develops here, and you'll watch this from the southwest to the north get shot up here as a pulse, okay? This is a pulsation that's going on right now, and it's still happening. It's within this box. It shoots up this way. This is a help to excite this. It's shooting an electromagnetic frequency through here, and you see this lifts up. So this is one case where you can pick out excitation artificially here, and then as we go on through this, we see another case of this occurring. This time we're watching this area of convection, and this area of convection, and there will be an imaginary line that you can see where this energy transfer is happening. This convection, this moisture is helping to feed Milton and grow it stronger. Here's a case again where we'll see this rotating clockwise to get the spin. We're exciting this, we're sending frequencies, we're transmitting water vapor, we're EMF pulsing this to help build this. Here's where you'll see the second area of convection attached to this area of convection. This is transferring energy. We're watching an energy transfer happen here. All this is happening while this is being constricted and confined to these bounds. Here's another one as well that's exciting from the south-southeast to north-northwest. And again, we can see this running right through here, that this is sending this pulse and exciting Milton. We see another case of this happening right here where these areas of convection are communicating with each other. This is the center of this disorganized area of thunderstorms that is, again, helping to supply Milton with the convection necessary. Again, here is another boundary I didn't draw out. It's right here. You can see another boundary right here as this continues to rotate. We see a case here where this is the channel, this open channel where this is coming this way, and it's helping to transmit these pulses for us. Here is that ionized channel, and we can see it through here, guys. Look at the lining on this. This is where it's being excited, and we see it coming through this way. And I want to note, you can see this yellow orb I drew. This is some of the resonance. You can see that this is being pulsed. And you can see what happens is, in return, is there's contracting going on here when these yellow lines. After this transfer is occurred here, we see that these two areas are communicating with each other. This energy is being pulsed right through here, through the center of the storms. Anywhere where you see the black and reds here, this is where the transfer is happening. After that, we see this have a return. Consequence of this, as this is fanning out, helping to excite this, we see this gets pinched and it compresses. We see compression going on through here. All of this happening is a consequence of seeing this transfer occur, guys. And I will point out again, we can still pick out a line here, a line here, a line going on through here, a line through here. And what happens is again, I'm going to say this, is this creates, it's a grid, guys. It's like an electric grid. And here's a case where you can have these rotating here. And maybe as this is rotating, you're shooting a frequency this way. Okay? You're shooting this and exciting this. And that's what we're seeing happening here. We see a case again where this is like pizza, like slices on a pizza. It's all being sequestered here. Here's your continued pulses of being shot through here. Here's another one that's helping to lift this up. And as you'll notice here with this yellow arrow is rotating this way. It helps progress this, guys. Here is another case where you can see the northern edge of Milton. And again, we see this occurring with this, but the northern edge of Milton is being constrained here. It's being allowed to lift at the expense of this boundary. Here we see another energy transfer occurring through here, through linear convection, linear thunderstorms. And we see, again, here's another pulse of convection that gets shot up this way and rotates, again, clockwise. This is all happening through this channel that this is being excited. Here's a case where we can really see a lot of these grids, the gridded EMF pulses that are being transferred here. And it just goes on and on, guys. Here's another one I want us to note with this. Watch this. As this develops here, we can see a node, a node, a node, a node, a node, and another node here. And they all pop at the same time. They all develop. They all come out and form thunderstorms simultaneously. This is, again, a case of a grid that's being manipulated with pulses and frequencies and rotating in a clockwise fashion. While all of this happens, this serves the purpose of stitches, of patches. You're patching this up. They're working at timed, calculated efforts here to manipulate this and to get this to spin. Here's another frequency that's shot off here. All of this is helping to progress and rotate clockwise. You'll notice the same theme over and over again. We see gridded pulses of convection. After they're shot off, they rotate clockwise, and that helps to fulfill the purpose of this being excited. And here again, we see the dry air being brought down, funneled down here. It's being funneled here in a case where we have clockwise anticyclonic flow here. This is high pressure that's helping to bring in this dry air. Here's again a case where we can see this is pinched off just like this. Guys, this is over and over and over again. Even as I stop here and draw my eyes over here, you can again see dry air is being manipulated over here. This is all cases of water vapor manipulation being brought out here. Let me go ahead and exit out of this drawing here. Once we continue to work through with this, I'm getting kind of to the end of this run here. It's thinking right now. I'm getting kind of the end of this run, guys. I'll go ahead and back up and just run through this again where I'm not talking. I like to have a case where I let you guys look at this and kind of draw these out yourself. Here's again a case where we see triangular sequestered convection across the coastline of Florida. That's all being moving in unison again along these red lines. And then towards the end of this, again, we see a case where everything is rotating this way. This is being torqued, all right? It's being lifted. While this end lifts this way, this end's going this way. It helps to thrash this and move this around. It's like frothing the waters up, so to speak. And anywhere where I draw these red lines is where we see this same linear nature of these frequencies being transmitted. This is another case where we see these are communicating with each other. We see a pulse is shot off through here. It's most pronounced through the two yellows here, where we'll see this move through from east to west. And then we see this convection, these greens shut off. They turn off because this pulse has already been fed through this channel that I've outlined in this red rectangle. This channel is active right now. What happens is it's being shut off. You see this turn off. And we see an area of new convection being turned on down to the south. So what this will now do is this will again help lift up this way. Like so. So guys, I'm going to go ahead and I'm going to walk through this again, frame by frame, without me speaking. I want you guys to just see how these are rotating together. Takes a very long time to go back with this. I gotta let this thing think. And this is a lot of work, guys. This takes over 200 frames of data to go through with this and show this stuff to you, but it has to be done this way. It has to be done in a way that's taken frame by frame so I can help bring out and show you what I'm seeing. And I'm telling you that the fact that this can be done in of itself alone, the fact that we can do this, we can pick out lines, we can pick out areas of convection forming along these lines, and when we can see energy being transformed along these lines, already throw out the door that this cannot be occurring normally. It just can't, guys. That's my point. I'm a broken record. I understand that. This gets me very energized and pissed off. It gets me very upset. So let me go ahead, again, I'm going to continue to back this up here, frame by frame. I'm just rambling at this point right now, guys. I'm filling this in as we're trying to back this up. But we're, again, continuing to roll back in time with this here. Bear with me, we're on slide 85 of 238 as I continue to back this up. Actually, it might be better if I just escape out of this. Discard the annotations here. Okay, here's a clean run. discarded the annotations. I'm not going to talk. I'm just going to hit play on this, and I want you guys to absorb this. Watch this, how this all works in tandem, how energy is being transferred here through electromagnetic pulses. Let's go from the current slide here. So that's it, guys. I'm going to run through it one more time so we can see it again. If we think bigger picture on this, it's a whole machine. That's all this is. It's calculated efforts of sequestering, manipulating, transferring, and moving our water vapor. And it is an incredibly complex process. There are thousands of these going on all at once. I'm just picking out ones that are, again, most obvious, and we can see that this is like a contraption. It's moving like it's a contraption. So last time, I'm going to run through this for us, guys. Here we go. So this is what we're dealing with here, guys. It is 2024. The future is here. And I will want to state again, weather modification is nothing new. This stuff's not new. They did this back in Vietnam War in the 70s. This technology exists. It's being practiced. It's being done today. Anyone that's part of these organizations, NHC, National Weather Service, NOAA, NASA, if you want to work for these companies, you have to sign a non-disclosure agreement. You cannot talk about any of these things, guys. If you do, you don't have a job. You lose your job, okay? They're complicit in this. They won't admit to it. No one's going to admit to it. And I want us to look at the realm of this as well, guys. If you manipulate the weather, if you can control the weather, you can control the markets. You can control money. If you want to decimate agricultural farms, ruin people's livestock, well, then you can go in there and foresee that happening financially, okay? If you have insider information that you're going to ruin crops, ruin agriculture with severe weather and flooding, which they did in May of this year, they were already doing that. It's the same thing that applies here. They're ruining your property. They're ruining your livelihood. These are weapons of mass destruction. This is a modern age warfare, guys. It's different. It's a different flavor of war. They use these things, they come in here, and they ruin people's homes, and they ruin livelihoods, okay? And in doing so, this can influence markets. You can get insider information on this stuff, guys. That's the why behind this. If you realize why would they do this kind of stuff, it's because you can control money with this. It's that simple. If you can control this, you have ultimate power and control over these things, guys. That's my point with this. These things need to stop, okay? They have to stop. They will not stop until we have enough people coming out and talking about this. Please share this. Please show this to other people. This is not normal weather that's happening, okay? It's my duty to tell this to you guys. I'm trained in this. This is my profession. I've loved the weather since I was 8 years old, and I am realize here that this is a nightmare now. We're living in a nightmare. It's a dream turned to nightmare, guys, and it's a privilege. It's a blessing to be able to forecast the weather, alert you guys, show you guys these things, okay? I'm just doing my job, and it's your right to know what's going on with this. Thanks for listening, guys. I appreciate you guys all so much. Hope you guys all stay safe out there. Take care.